Looks good. Okay. Good evening, everybody. How are you? Very nice to have you guys here. I see we have chairs. I like that. Hopefully you guys have some bug spray. Uh-oh. Well, you know what? During the presentation, I have a little can in the car. I'll wipe it down, and I'll set it over here if you guys want to spray a little spray on yourselves, okay? But just real quick, before we get into the talk, we do have our small gift shop over here. We do ask that if you folks still go inside, if you can go in one at a time, but if you are a child, you may be accompanied in by adults. We encourage that. Next to me over here, beautiful donation jug. Everything we do up here, we want to keep 100% free. So the way we're able to do that is by soliciting donations. So if you folks are able to, we have the jar here. You can also donate online at UACNJ.org. Scroll down on the home page and it's in the bottom left. And tonight's program, I know, was originally going to be done by Greg, and we were going to speak to you folks about the Northern Lights this evening. We did have something come up. Greg had an emergency. He had to go and take care of something. But even better, we have my good friend Paul. Paul is also the vice president over here at UACNJ. So all the work that Paul does, we really appreciate it. All the hard hours he puts in here behind the scenes. We thank you very much for everything you do, Paul. With that being said, I'm going to turn this over tonight, and Paul is going to talk to you about, I bought a telescope, now what do I do? Which is a very good question, because a lot of us, sometimes we come here, we get real excited, we want to buy a telescope, we start to look at telescopes, and then we don't know what to do. So, Paul is going to give you guys all the answers. With that being said, I'd like to turn it over to Paul tonight.
Now? Okay, good. Sounding good, buddy. All right, everyone. As Matt said, you bought a telescope. Now what? Not only is it for people who actually bought a telescope, but maybe you are thinking of one, or you can actually do a lot of astronomy with just a pair of binoculars. A lot more people have binoculars, and there are plenty of things you can see in the sky with binoculars. And a lot of times, the way many guides actually how you start in as an amateur astronomer is just by using your eye, going out and getting familiar, because it takes you a full year to see, of course, as the sky rotates around us, or as actually we're rotating and the sky stays still. It takes you a full year to see where everything is and to start making that relationship. So some actually recommend, hey, wait a year before you actually purchase any equipment. So any of those ways, really a good way to start. So let's dig into it a little bit. Holy smokes, a war story already. Yes, I'm going to tell you about how I started. And you'll see right up here, this in the middle here is Jupiter, and maybe these guys right here. And I saw that thing up in the sky. I didn't know what it was, and I said, I bet you I think that's Jupiter. And I took a pair of binoculars and I laid down on the flat roof portion of my house, looked up in the sky with the binoculars, was able to hold them on the end. Everyone knows to hold binoculars by the end, right? Okay, that keeps it a lot steadier than if you hold it closer to the eyepiece. So hold binoculars by the end. And once I did that, I was able to hold it steady enough that I could, through the binoculars, make out the Galilean moons of Jupiter. And I was really excited. I bought a bunch of books. I bought a telescope, and now I'm up here presenting to you. So it takes an aha moment, something like that, maybe to get you started in amateur astronomy. So I just told you about that. I had a shiver of realization. And these are some more famous people, one of them saying, Sir Isaac Newton, if I have seen further, it is by standing on the shoulders of giants. So what I was actually looking at once I saw the Galilean moons, once I saw Jupiter, was the same thing that people saw hundreds of years ago. And then they started putting together all the physics of mechanics and gravity and all the modern sciences, basically, by making observations like that. And you can maybe get a glimpse of their minds. Yeah, here's the point to that story. What is a model and why is that relevant, right? So why is that this whole thing pertinent? And the reason is let's talk a little bit about models. And I talked about the sky moving above us or us rotating underneath the sky. Well, sometimes it's convenient to think of it one way, and one time it's convenient to think of it another way. So we know at this point that the Earth, on a day-to-day basis, is rotating 360 degrees, sort of. From a sidereal perspective, it's quicker than that. From a little bit longer than that. From a day-to-day perspective, sitting on the planet, it's 24 hours. But we know we are rotating around our axis. And so the sky, the stars, at least to our around our axis. And so the sky, the stars, at least to our perception, they are moving. Everything is always moving. But as human beings, they kind of stay, the stars kind of stayed in the same place evening to evening, year to year. And we, as we rotate and as we orbit the sun, it is moving to our perspective. So we can think of it as the sky is moving, but we know reality is that we are moving. All right, so those are two different models. One, the sky moving. One is hello? All right. And so we can switch those models out depending upon whether we're talking about reality and need to do some or whether or not we're talking about trying to find things in the sky from an amateur astronomy and other astronomy perspective. We can sort of say that the sky is moving, and that makes sense to us. It's just a model that we're using. And we're also going to find out why I think astronomy is really, really cool. All right, I talked about a little bit about that shiver of realization that look into science in general. All right, what is a model? A model is simply a simplified representation of an imagined reality that enables predictions to be developed and tested and experiment. All right, so what's that really? You're taking, you want to make predictions. Your model is an understanding that you use to help you make predictions about how things are going to act. And this is kind of said tongue-in-cheek. Science, philosophy, religion, etc. universally agree that humans exclusively use models to understand reality. That's not true at all. I put ha back there. As long as there's been philosophy, religion, and science, they've butted heads on what to help us understand. Talk about the celestial sphere. So that's our first step maybe in understanding amateur astronomy, is that sky, as I said, we know that we are really moving and rotating, but to us it appears that the sky is. So let's talk about a little bit about the celestial sphere. Let's just pretend we forget about reality and say, oh yeah, the sky's moving above us, and that sky is called the celestial sphere. And the celestial sphere is the globe. This is the Earth. That's our globe as we see it sitting on a teacher's desk. And then the celestial sphere is a globe that is outside of us. We're looking at the inside of that globe, so to speak. And that's this guy around. And it has features such as the ecliptic plane, which is similar to our equator. It has our equator projected on the inside of it, so the globe's equator is there, and then our equator is projected. And then it has these ups and downs, and we'll go into those ups and downs and meridians left and right on it, just like a globe does. So think of it as a globe that we are seeing from the inside out. Now, how do we understand all these concepts? I just went through that really quick, right? And you probably don't understand it much other than that I've just introduced the concept to you. Well, amateur astronomy, the universe in general, right? Really, really big thing. No one can know everything about it. Amateur astronomy as a hobby, really big thing. So how do you attack amateur astronomy, or how do you eat an elephant? One bite at a time. You learn one thing, you put it in your brain, you cogitate on it a little bit, you look through a telescope, figure it out, and then another thing, and then another thing. So don't worry about trying to get all these concepts immediately in your brain tonight. You're going to get it one little bit at a time. So don't look at amateur astronomy as something you can read a book and be expert on. It's not going to work that way. All right, let's go into telescopes a little bit. This is a light diagram of a refracting telescope, and I want to show you here. This is the light coming in this way, and it passes through the objective lens. That's the first lens that it meets. Okay, and then I really like this because what it's showing here is that it's creating these rays here as the light goes in, and it's creating an image at a set known distance inside the telescope. You need this second piece here, which is called the eyepiece. And it is creating rays that happen to coincide, not happen by design, coincide with that image, and then those turn into lines that go in the eye. And that's what's creating the focus, and that's what's allowing you to see the image. So a telescope in general needs an objective and an eyepiece to see an image at a certain magnification. So you need all those factors in order to see through a telescope. Here's another type of telescope. You maybe have a little more difficulty seeing the light diagram, but what's happening here is the light's traveling this way, hitting a mirror, then hitting another mirror, and then going out the eyepiece this way. So again, it's an objective. This time it's a mirror instead of a lens. It's hitting another mirror, and all that mirror is doing is changing direction of the light. And then it's going through the eyepiece, which is also focusing on the image. And then you have CATADIOPTRIC, and a lot of the telescopes you'll see here tonight are these type of telescopes, and they're a mixture of both lenses and mirrors. And so their light paths are a little bit more complex. This one, the light's passing this way, hitting the mirror in the back, hitting a mirror here, and these both have curves, and then both cause a focus in the back. So you can tell the CATADIOPTRIC by the light path going through the back of the telescope. So understanding a little bit more about telescopes there, what's the main telescope's purpose? The telescope's main job is to make small objects that are far away bigger, right? That's not its only job. It has two other jobs. One of them right here is if you look at the naked eye, which let's see, the radius of your the portion of your eye that sees the pupil is about 3 millimeters. All right, and then there's some math here, and I'll go into that in a second. A 4-inch telescope has a radius of 50.8, and an 8-inch telescope, my personal telescope's an 8-inch, has 101.6 millimeter radius. Well, I did a little bit of math, and I'm sure the cross-sectional area radio gives you an idea how much light power that those telescopes have. Your naked eye, if we call that's just normal, we'll call that 1. Then an 8-inch telescope gives you almost 1,200 times the amount of light into your eye. So you know not to look at the sun with your naked eye. Imagine the problem looking through an 8-inch telescope without doing proper things, that's 1,200 times the amount of light gathered going into your eye. So what is that doing? That's making dimmer objects brighter to your eye. So you can see dimmer objects better. All right, so if you look at any of the telescopes, the area that I'm talking about, the 8-inch telescope, would be just where the light goes in the front of the telescope. The second thing, and I don't have a slide for that, the second thing is that telescopes do help with detail to a certain extent. We are somewhat, and the reason that people don't talk about that too often here, sitting here as amateur astronomers on the planet Earth, is that the atmosphere will interfere with that a little bit. So up to about 5 inches, the telescopes will allow you to see more and more detail on an object you're looking at. Now that doesn't count necessarily for stars, because without using interferometry, you really can't resolve the disks of stars, and only the closest and biggest stars can we really resolve that disk. Betelgeuse, we can. Most other stars, in fact, almost all the other stars, we can't. So you really can't resolve the disk of stars. But planets and other things that have a larger width, like clusters and nebula and things like that nature, and planets, we can resolve those disks and we can see further detail on them up to about 5-inch telescopes with an amateur level telescope. Let's talk a little bit about eyepieces, because eyepieces, everyone knows about the telescope, but maybe not everyone knows about eyepieces. These on the top here are just examples of common eyepieces. Plossl you'll hear a lot, and a lot of these others you'll hear, and Nagler here is a famous proprietary eyepiece. Okay, these are multiple or compound lenses with coatings to eliminate the image distortion, the aberration of what the image that you're seeing in the telescope. So what does that mean? They are basically as complex as the telescope itself. So they are like mini telescopes. They're bending the image back and forth, bending the colors of the image back and forth, so that you're seeing as clean of a image as you can. Plus, you always need an eyepiece as the second part of a telescope in order to magnify and to make it focus and work. So that it provides that purpose, that basic purpose also, of course. The eyepieces, the focal length of them are always expressed in millimeters, and that'll be printed right on the eyepiece. They're available typically in 1 1/4 inch and 2-inch sizes. A medium grade eyepiece can rival the cost of a beginner scope. So if you are looking to purchase a scope and you want to have a selection of several eyepieces, then you would need to take that into consideration. Just like when people say, if you have to ask how much it costs, you can't afford it. Well, if you're just looking at the scope's value, you have to take into account maybe some of the eyepieces too, and some of those accessories. There's also other things, a reticule, a Barlow, and an angle viewer. Those are also accessories that are basically similar to eyepieces. They go in the eyepiece position, but they help rectify the image, or they'll bend it so you don't have to bend all the way down to look into your scope, that type of thing. So they help. And then learn your scope, the bottom line, literally, learn your scope with your default eyepieces. A lot of scopes will come with 1 or 2 eyepieces. Use those, get comfortable with it, and then maybe consider buying eyepieces afterwards, additional eyepieces, as you identify your needs. Some eyepiece terminology, you'll hear the word exit pupil. That's the image height exiting the eyepiece. That you don't really need to know unless you want to start doing maybe some calculations based on how much of an angle am I looking at in the sky right now. Eye relief is important to know, especially if you're wearing glasses. That's basically there we go. Exit pupil, eye relief, basically that's how close you have to be to the eyepiece to see through it. People with eyeglasses might need a little more eye relief in order to comfortably view images, especially if you can't correct your vision by using the focus of the telescope. The apparent field of view and the true field of view. The apparent field of view is something that the eyepiece manufacturer will tell you, and then your true field of view, something you calculate based on your telescope and the apparent field of view that you got from your eyepiece manufacturer. All right, let's talk a little bit about mounts. Telescopes have mounts associated with them too. There are two major types. There's the altitude azimuth. One of the popular versions of that is a Dobsonian mount. They're easy to set up and intuitive to use. They're artillery-like. So you just swing it the direction that you want to look in the sky, and then you up and down, and that's very intuitive, just like you would imagine artillery is done. And they're telescope or Earth-centric. You need to know more about the sky using those in order to find things. There's no intelligence related to how the mount is set up to help you find things in the sky. That's not true about the equatorial. The equatorial mount here is a little harder to set up and less intuitive to move. Electromechanical tracking, you can get it actually in both versions. This is actually cheaper to get electromechanical tracking using these guys, but this electromechanical tracking allows for a little bit more utility, especially as far as astrophotography goes. And it's sky-centric, so that celestial sphere we were talking about, you can actually align the equatorial mounts to the celestial sphere, and that aids in that coordinate system that I briefly introduced you to find things in the sky. And then you have a push-to and go-to type of mounts. With modern electronics, computers and controllers for amateur astronomy makes your mount choice somewhat less critical. Like I said, you can find computer-aided and motor-aided stuff for both of these types of mounts. Other accessories include red flashlights, red dot finder, green laser pointer. It's basically this thing but green, so it displays in the sky. Whoops. Whoa, where did I go? There we go. A green laser pointer, a broadband filter might help you with bright object, or you can see some nebula with a broadband filter. A case to protect your telescope when you're storing it, and a bench or chair. So not only does a telescope need to stay still and stable when mounted, but as still and you can make yourself helps with seeing things through a telescope. Now, I wanted to, before we get too much further, wanted to go through a couple of these concepts with you. So I'm going to introduce you to a fake constellation. This fake constellation is Bob the Accountant. Okay, and right here is his, in the pocket protector position, of course, is M401K. All right, so Bob the Accountant if we remember the celestial sphere a little bit, let's think about how it moves in the sky. Let's talk about north is kind of this way and south is kind of this way. So if you think that I'm an observer right here, I'm going to look at Bob the accountant. Let's say that he's somewhere near the North Star. East is kind of that way and west is kind of that way. And say the North Star is right here. Bob the accountant would go around the North Star like this. And if he's really close to the North Star, he might just turn in the sky like that. So you're seeing the top part of a globe, basically, the inside of a top part of the globe. So all the north constellations and any of the objects around those constellations would follow that pattern. Now, let's talk about the southern part of the sky. Again, this side's east and this side's west. We're missing completely half of that circle. So we're going to see the rising and falling of Bob the accountant. And then we're not going to see the other half, which is him going around this way and back up again. Okay? So the rotation's the same, just in the rotation is the same. We're just missing half of it when we're looking here in the northern hemisphere at the southern sky. Does everyone get that? So that's Bob the accountant. And let's see. Let's talk about the equatorial plane just a little bit. So this is the Earth. And these red guys are observatories. And you can see that here is the Earth's equator. And this is our true, as best as I could make it anyway, our true tilt of around 23 degrees, somewhere in that range, in relationship to the equatorial plane. So this is a true tilt of the Earth as it rotates around the sun. So here's the sun. So on this side is our current position, where the northern hemisphere is leaning towards the sun, and this is us leaning away from the sun in winter. Everyone got that? And you can see if you are on the daytime side here, the sun is high in the sky compared to the observatory. You're looking up sort of at the sun, right? And anything in the equatorial plane, which is as the planets are all in. So sort of like that in the equatorial plane. Anything that we're looking at is low in the sky, because here we are, same observatory at night, looking down at it. Okay, so the equatorial plane is low in the sky in the summer in the south. Does everyone see that a little bit? All right. All right, so I explained that a little bit, and let's talk a little bit about, now that we kind of have our telescope set up, we have our mount and all that type of stuff, what can I do to enhance how I'm using it from a practical standpoint? It takes about 30 to 45 minutes for full adjustment of rod cells. That's why when you'll hear, maybe you've heard rumors, hey, I should be using a red light. That's not necessarily true. Use a dim light. That's the most important. But a red light helps. In maritime situations, they use red light, and we appreciate it when you do it in astronomy. But any dim light will help. And so that's why we say, because it takes that long for the cells in your eye to adjust, you need to wait a long time until you can see everything that you'd like to see in a telescope. Averted vision is another way to help you when you're looking in a telescope. What is averted vision? At night, you might notice that when you look at something straight on, it disappears a little bit. But if you look away from it by just a little bit, then you can see it better. And that's because your rods are on the periphery of your vision. And so if you don't look directly at something in a telescope, the same thing applies. If you look a little to the side one way or the other, you will be able to see things in the dark a little bit better. That includes telescopes. Motion's another way of doing it. Now, your eyesight is very keyed into motion. If someone moves quickly, it can catch your attention. Same thing happens in a telescope, but you can do that by moving yourself a little bit, by moving your eye a little bit in the eyepiece, or if you feel brave and it's your telescope and you're driving the telescope, or if the telescope owner allows you to adjust it yourself, then you can move the telescope a little bit, and it helps with finding things in the telescope. And then finally, let's talk a little bit about surface brightness in deep sky objects. Surface brightness is that the concept that as you magnify, you are creating a situation where you are spreading the light from that object on a bigger and bigger and bigger area to your eye. And it's quite possible that if you magnify, if you switch out one eyepiece and put another in there, refocus, and now at a different magnification, it's possible for you to magnify beyond your ability to see that object anymore. Because objects that are spread out, you are spreading the light out more and more, and now that it's too dim for you to see. Learning the sky. Remember that elephant we talked about earlier. Lose the scope and appreciate the scope. I still go out like at the change of a season. I haven't been out in a couple weeks or a month or so, and I look up and I just reorient myself in the sky, learning what's up there and what's next to each other and what the possible targets are in that area from some of the research I've done. Does anyone know this evening what might be an important object or important reference asterism to see in the sky this evening? What's like really prominent during these summer months? That's a hint. It's called the summer triangle. If you can find the summer triangle, you can find the Milky Way, and you've identified a good portion of the sky, and you can start to see where everything is in relationship to each other. So have one of the amateur astronomers around here point out the summer triangle to you this evening. Navigation aids, and I have more props. I actually have slides for those, so I'll do that then. Realize your cheating brain too. So if you go to and do amateur astronomy in one place, then you're kind of learning the sight and you're not learning the sky. You want to force your brain to learn the sky, and that means traveling to places like here, traveling to maybe other people's backyards, your own backyard, other places, because now, see, I can go like this, and then I know I'm generally right, the North Star's right there, because I've been here often enough that I know the North Star's there. But if I go to another place, then I'm actually trying to figure things out based on what stars I see. And you want to do that to yourself. Get rid of these ground visual cues and start learning the sky itself. To help you with that, a lot of amateur astronomy clubs, and up here, of course, go to sky parties and other events to help you with that knowledge. All right, PLANISPHERE. I have a planisphere right here, and you can see this goes around, and I can dial in the date, dial in the time, and up here is a simple star chart. Shows me what constellations and some major targets, what are up there in the evening. All right, but I wanted to show you something, and it's true for any of the navigation aids. Can you guys see that, the directions on that? Can anyone see that? Yes or no? No. Okay. I'll point them out to you. North is here. South on the sky chart is here. West is here, and east is here. Can anyone tell me what's wrong with that? Yeah, east and west is reversed. Do you know why? You're not supposed to, so north is this way. You're not supposed to read it like this, because it tells me that west is over here, but it's not really there. Oh, well, here's a bigger one. Why don't you, well, I'm going to leave this one here. Maybe you can take a look at it a little bit later. Thank you very much, guys. So you're not supposed to read it like this. That's what the problem is. Remember, it's a chart of the sky. So east and west are going to be reversed because we're looking at the inside of the sphere, not the outside of the sphere. All right, so in order to make sense, don't look at it like this. Until you get used to it and the flip-flop in your head, hold it up into the sky like this, or however's comfortable. That's how you have to read it. All right, and that's true of any of the sky charts. Star Atlas, just wanted to show you the Cambridge is a good one. And it's relatively portable. And you can come up and take a look at this too. I'll leave this over here. And it shows a lot of stars and a lot of targets, and it has a lot of target information, and it's definitely a good one to get started. But take a look at this one. So this is 6th magnitude. What that means is stars up to the 6th magnitude, that's a certain level of brightness, are in this chart. Stars up to the 11th magnitude. There's a lot more stars that are further away than us and a little bit dimmer. And so it goes from something this size to something that starts looking like the Encyclopedia Britannica, right? So this might be a good reference for somebody who's really serious about astronomy for their desk, and this is something to take out in the field. Okay, and I was supposed to show something else. That's probably that's probably those two things that I just showed you. And here's the final thing. Everything's on the computer now, or on a tablet or phone, and so this here is a Star Atlas application, and these guys are really good, but they give a small view of the sky. So you still kind of need these guys if you're planning out looking at objects in the sky, because this just it's not big enough window typically to give you. It's great for giving you a lot of information and maybe exactly what you're going to see, or the stars and stuff you're going to see to a certain magnitude in the sky. So it's great for doing that, but a lot of times it doesn't give you an overall appreciation like the bigger app and the planisphere does. So maybe use all of those things in conjunction. All right, what can we find in the sky? If you are just beginning, maybe this order or some of the tasks, the task lists, so to speak, to take on. The moon is an awesome object. People want to see other things besides the moon, and I don't blame you. but the moon is the closest thing to us, and the detail level that you can see through an amateur telescope is unbelievable. You can reach out and grab it. It'll take a look at the moon through your telescope, definitely, and spend a while doing it. You can see a lot of detail. The planets, Jupiter, Saturn, Mercury, Venus, Mars. Those are the planets that the ancients knew about. Those are the 5 usual suspects. Definitely take a look, and we'll definitely see Jupiter and Saturn tonight. Stars, deep sky objects. There are globular clusters and open clusters. Clusters are just groups of stars. Globular and open are 2 different types. Nebula, which are just big gas clouds, clouds of basically hydrogen mostly, helium, and some other stuff, and dust. And then galaxies are extraordinary to look at. And then finally, some of the outer planets are cool to find, and some of the bigger asteroids. And transient objects. Of course, we just had that comet come by earlier in the year. Definitely something to take those things when they're available. Take a look at them. You might hear about Messier objects and NGC. So there are catalogs, and the Messier and NGC are older catalogs, and there are people who hundreds of years ago, in some cases, were taking a look at in the sky and just wrote down everything and where their position was and listed them and gave them numbers. So when you hear M13, for instance, the Hercules globular cluster, that's Messier just took a note of it and assigned it a number, and that's all that M13 means. So who was Messier? He was Charles Messier, 1730 to 1817. He was a comet hunter, and he himself discovered 12 of those. Ironically, we use that now as sort of a beginner's catalog. These are the things you should start looking at as an astronomer. This is the way we use them, but he used them as things not to look at because they weren't comets. And originally it had 103 objects, but it was then expanded to 110. The NGC IC catalog was compiled by John Lewis Emil Dreyer, and he built upon the work of the Herschel family, who had begun a catalog. It's called the New General Catalog Index Catalog is its full name, but everyone calls it the NGC IC, or just the NGC catalog. Originally had about almost 8,000 objects, and it's supplemented by 2 major updates, and that's the IC catalog, and that's an additional almost 5,400 objects. And it has since been revised a number of times, which is now it's called the revised NGC IC catalog. All right, I told you about detail, seeing a little detail. I took this picture from my cell phone in my telescope, and like I said, the moon's a great and amateur astrophotographers, will tell you that this is probably a horrible, horrible picture, and they're 100% right. But just seeing that that's a horrible picture and the level of detail that I can get from a cell phone through my telescope is still astounding. Imagine what you can see with your eye on a good seeing night, and then imagine what you can see with somebody who really knows astrophotography. Stars we talked about. There are some things like the magnitude. This is Sirius here, very bright star. It's actually causing a lens flare, and it's that bright. It actually can be uncomfortable to look at in a telescope. And then look at color. This is Albireo. We can see Albireo tonight. I don't know that we have necessarily color astrophotography for you tonight to be able to see it, but through a telescope you'd be able to see that guy's there noticeably bluer, and this guy is maybe on the orange-yellow scale over here. So when you get to see Albireo through your telescope, one of the things to notice is the various colors of the various stars. Outer planets. If you, like I said, you can stars you can't resolve the disk, but the outer planets, even though this is fuzzy and you can't see any details, and I don't have it written down here, unfortunately. I believe this is Neptune, and Neptune is you can see that it actually has thickness to it as opposed to just being a point of light like a star would, and it's actually a pretty color when you see it through the telescope. And galaxies. This is Andromeda. Andromeda isn't quite up yet. Maybe later in the evening it would be up for us, but we'll be closed tonight if that happens. And Andromeda is definitely, there's actually a satellite galaxy there and a satellite galaxy there. But Andromeda, you can see, goes all the way across. You can see some nebulosity, they call it, a little bit of fuzziness associated with the larger disk of Andromeda, and this is sort of the core here that you see right there. Definitely interesting objects to see. Everyone's favorite subject. There's a little bit of math, and no, you don't have to worry about partial differential equations and all that type of stuff. It's just kind of simple math. These ones you'd kind of want to know just so you start to know some of the things about the sky. Magnification, the magnification of what you are currently looking at in your telescope is the focal length of your telescope, which you can read off of the manufacturing data that you got with your telescope, divided by the focal length of your eyepiece, which, if you remember, I told you is printed right on the side of your eyepiece. Then your true field of view versus is your apparent field of view divided by the magnification you just got from the line above. So you then know what angle you're seeing in the sky, and we'll go into that just a second. You now have all the math you need to create an eyepiece chart for your telescope and to start to understand a little bit more about how much and what you're seeing in the sky. And on the back of Bob here, this is what we're talking about when we see a field of view. There's a guy just standing on a planet, or a lady standing on the planet, and through this angle here sees this object in the sky, and they don't know how far that object is necessarily by looking at it, do you? So you don't actually, if you remember trigonometry, you would have to know this distance in order to know this distance, right? The angle, the tangent would tell us that information. However, we don't, just looking at an object, necessarily know how far away it is from us. A star could be close, a star could be far from us. So we don't know. So we always use this angular measurement in order to talk about how far things are from each other. So we'll start to understand that if I have a field of view of 5 degrees and I'm looking at my chart and it says I'm 10 degrees away from the object, I need to move my telescope how many fields of view? 2. I got to move it over 2 fields of view, and that's it right here. Here it looks like I can get 4. This object is about 4 fields of view in width, and if I wanted to move it to this side, I would have to move it over 4 times in order to see it. And that's how you get to appreciate how to find things in the sky, is by knowing how much of the sky I'm looking at one time. Give me a second. There we go. Let's talk a little bit about the coordinate systems. There's altitude and azimuth, which we talked about, sort of similar to the, we did talk about on all that azimuth. Azimuth is how far east of north you are. Altitude is about how far above the horizon you are in degrees. Right ascension and declination are actually pinned to the sky, whereas alt-az is pinned to your current location on Earth. Right ascension is how far east of Aquarius you are in hours of right ascension, and declination is how far above you are above the equator. And in order to convert right ascension to azimuth, you have to use this ridiculous formula, and it's ridiculous because you start talking about arc minutes and degrees, and those minutes, arc minutes and degrees mean different things if you're talking about right ascension and azimuth. So I'm not going to tell you how to do that right now because you have to sit down and scratch your head a little bit to figure it out. But just be aware that they're actually using two different units with the same name. So a little bit hard, makes it a little bit harder to figure it out. Another technique we're going to talk about is star hopping. Star hopping, so we're talking about computerized mounts, and a lot of people use them. Won't I just be able to start up my computerized mount and then find things in the sky? No, you need to start by, a lot of times, by aligning your scope, and which means you still need a certain knowledge and the ability to find certain things in the sky by yourself, because you have to help the scope figure out what it's pointing at. So you can't avoid it completely. That, and if you turn off your computerized guidance, you'll learn the sky a lot better, and if something's going wrong, it'll enable you to troubleshoot a little bit better. And finding stuff in the sky, at least I find it fun. So what's star hopping? We'll be able to see Vega tonight. It's part of the summer triangle, and what's neat about it is here is a popular object, M57, the Ring Nebula. It's a planetary nebula, and the Ring Nebula is kind of see, but it's also easy to find, easy by star hopping, because I can go from Vega, which is a very easy star to find in the sky, star to find in the sky, and then hop over to this star using my scope, hop over to this star, kind of see where this star is, and go, well, if I go halfway in between them, I should see the Ring Nebula. And that's what star hopping is, just finding it from star to star to star, and then that way you can find the Ring Nebula. So if you haven't, try using star hopping to find the Ring Nebula. Probably one of the easiest objects to find, deep sky objects. We're almost done. So this is your homework. All you have to do is read all these books. I put them in order. So if you want to start maybe a little bit, then increasing your library by 5 books immediately. 365 Starry Nights by Chet Ramo is probably the best place to start. Really good beginner level, and he introduced concepts not by explaining the concepts, but by showing you a target, showing you what you can see on that night, and then sort of introducing the concepts comment at a time while he's introducing you to those targets. So an excellent primer on amateur astronomy. And of course, the rest of these reference books and primers are also awesome to use. Lastly, I suggest everyone to join an astronomy club. Don't worry about not knowing everything. I didn't know everything when I first joined. I was a raw beginner. So you got to begin somewhere. Don't be embarrassed by it. Everyone here at astronomy club, at any astronomy club, this one, anyone you go to, are more than excited to show you what's going on in the telescope and to help you figure things out. A friendly bunch. Just wanted to mention astrophotography. We mentioned the purpose of a telescope. Astrophotography helps you with the detail, helps you with seeing detail, helps you with gathering light gathering power, helps you in another way. Just be aware that complexity and expense of astrophotography, I warned you about the eyepieces and the cost of the telescope. Astrophotography gets way more expensive. And here you are surrounded by skilled astrophotographers, so do ask questions if you want to get involved with astrophotography. And how does astrophotography gather additional light? Of course, exposure time is how astrophotography can gather a lot more additional light. So you can see a lot more or a lot dimmer objects through astrophotography. And how does it help with detail? Using software and tossing out bad images, but also handling the random nature of light. If you remember from school, light is both a particle and a wave. Well, some of that ends up in errors, and the astrophotography and some of the software used to handle the image can deal with those errors, so you get better clarity with astrophotography too. I think that was it. I don't think I wanted to talk anything else about Bob the accountant or anything else. So yes, that was the last one. Oh, I know what I wanted to do. I wanted to put up that last piece again for... Oh, yes, sir.
You do have 2 scopes open and the sky is clear enough. So.
Excellent. Thank you very much.
All right. As we've ended the presentation, are there any questions from out here?
No questions at all. Okay, what's that? I can't see you because of the light, so you're just going to have to speak up.
Sorry, here comes the microphone. Yeah. Somebody this week said that they were going to look at the Milky Way. How can we see a galaxy that we're in?
You're correct in being suspicious about seeing the whole galaxy. You can't. But of course, we are in a galaxy that extends for about 100,000 light years from side to side. So you get to see, say, in one direction, 60,000 light years of galaxy, and in another direction, 30,000 light years of galaxy. Okay? So you can see parts of the Milky Way galaxy. And tonight, if you find the summer triangle, and then in the summer triangle, you'll see Deneb, and Deneb is part of Cygnus the Swan. If you see Cygnus the Swan, you are looking at the Milky Way galaxy, or at least a portion of it. And if you look down towards the south, you'll see Sagittarius, and you'll see towards the center of our galaxy. And if you see up towards Cassiopeia, in the north, you'll see another side of the Milky Way galaxy. So the Milky Way looks like a lane in the sky, and it's actually the disk of the galaxy, and it goes all the way around us. And so in the winter, there's even the Milky Way there, and it's actually a lane in the sky all the way around us. So you're right in being suspicious. You can't see the galaxy in its entirety, but you can see definitely parts of it wherever you look in the sky.
Thank you.
You're welcome.
You do have another question? All right.
Anyone
got another
else?
question?
I actually have two questions. The first one is, August is supposed to be the month of meteor showers. Any meteor activity tonight?
There's always a chance for a meteor. I don't know that we have any active showers at the moment. The tail end of the Perseids, but I don't know. I don't know off the top of my head how active that is now, if at all. But anytime, always look up. There's always a chance of seeing a meteor.
And the second question is, I've already...
The 25th?
Yeah, roughly we can see them, and especially the way that the moon's working out, we're not going to see
Yeah, so there's it is not a, they don't operate like a train schedule, right? So certainly there's pieces and drips and drabs here and there all the time of various things floating around in the sky. But as Matt said, we're at the tail end of the Perseids. So there's a good chance. Look up.
So the other thing looking up was I've already seen at least 2 or 3 satellites going over. How many in northern New Jersey satellites at night are we going to potentially see on average?
Yeah, good question. Those apps that I told you about, the astronomy apps, a lot of times will tell you where the common or known, public satellites, shall we say, where they are and what time they rise and fall. So they'll actually give you warnings and tell you when those are available. I don't know the total amount, but I think there are thousands of satellites that can be seen. They'll be typically relatively close to the equator, a lot of them, but that's not necessarily true. There's polar satellites and many other types of satellites. And then let's face it, we all know about the military, and they don't tell us all their secrets. And there's a lot of satellites that are just simply not marked that are up in the sky that you'll just see fly by too.
All right. Were there any other questions? All right. If that is all, we thank you for coming out. Thank you, Paul, for being our speaker.
Thanks, everyone.
Just a reminder, our bathroom is right to the my right, your left. We do have a couple of telescopes open, or at least one telescope open. Oh, we do have 2 today. We are presenting on the screen, as we mentioned earlier. It's a little bit different, unfortunately, with everything going on. We can't allow everyone to be touching our telescopes just because the sanitation would actually destroy various sensitive pieces of equipment. We do have the sales desk right behind me. Feel free to come in if you're by yourself, one at a time. If you, of course, have younger children, feel free to come in with them. Other than that, as you do decide to leave tonight, please use your headlights. It is not fun getting run over. We don't ask me how I know this. We like to avoid that situation because it does hurt. And anything else? All right. Thank you for coming.